In this scenario, we're working with an e-commerce platform's checkout page. After the user clicks place order, a confirmation modal appears briefly before the page redirects to the payment gateway. The modal includes dynamic data like order ID, timestamp, and the user's name. The challenge here lies in the modal's transient behavior. It only appears for 5 seconds, and if not captured correctly, the test will miss it entirely. Think carefully. How would you approach validating the contents of this ephemeral modal using Selenium, ensuring it's captured in time before the redirect takes over? Imagine you're testing a travel booking web app with a calendar widget that's entirely built in JavaScript. This widget doesn't use traditional input tags. Instead, it dynamically renders calendar grids and navigations. The QA team needs to ensure that once the user selects both departure and return dates, the search button becomes active. Your test case must not only interact with a complex DOM, but also remain stable across varying load times and element IDs. How would you structure your automation to deal with non-standard elements and make this interaction reliable? Here's a real-world roadblock. You're automating the login functionality of a platform that includes both captcha and OTP verification. These security layers are not meant to be bypassed by bots, which means Selenium alone may not be able to complete the login process. The business still expects you to validate login flows as part of regression. What creative workarounds or techniques would you consider for handling this situation without compromising security, yet achieving sufficient test coverage? You're testing a banking app that heavily utilizes Shadow DOM to render elements such as transaction history, notifications, and digital cards. Selenium WebDriver by default doesn't have native support for traversing the shadow route. Your scripts are failing to interact with basic components like buttons and labels. In this case, you're required to go beyond default locators. How would you restructure your approach to interact with elements encapsulated inside shadow routes? Consider this use case. You're dealing with a React-based admin dashboard. It loads several widgets asynchronously, some in 2 seconds, others in 10. Some widgets are essential for business validation, while others are optional. A frequent issue arises where the test completes before all widgets finish loading, causing failures. How would you make your test resilient, aware of async delays, and still performant? Your strategy must intelligently decide what to wait for and what to optionally skip. Imagine you're testing a web application that supports over 10 languages, including English, French, Arabic, and Chinese. The core functionality remains the same, but labels, buttons, and layout flow vary. Your task is to automate validations across all locales. This isn't just a translation check. It's a full functional validation across different languages. How will you design your framework to handle locale-specific text, RTL layout changes, and country-based feature toggles? Your automation suite runs inside a Docker-based Selenium grid every night as part of the CI pipeline. However, developers often report flaky tests, especially when running on Firefox. Common issues include timeouts, inconsistent element visibility, and failed assertions. The staging environment is also slower than production. How will you proactively fix these flaky tests, optimize weights, and stabilize test runs across different containers and browsers? In this scenario, your app generates a dynamic PDF invoice upon a successful purchase. This invoice includes user-specific data such as name, plan, transaction ID, and amount. After the user clicks Download Invoice, the file is downloaded to their machine. Your job is to verify the content of this PDF. How do you programmatically read, extract, and validate that the downloaded PDF contains accurate and correctly formatted data using Java and your Selenium framework? Your app implements infinite scrolling to load content dynamically as the user scrolls down, very common in social feeds and long product lists. However, there is no Load More button. Instead, as the user scrolls, more content loads and is appended to the DOM. Your test case needs to ensure that all content loads without duplication or cutoff. How will you simulate this scrolling behavior using Selenium and verify that every data block expected by the backend is visible in the UI? Your application has integrated a customer support chatbot that responds dynamically based on user inputs. The chat interface uses real-time suggestions, asynchronous replies, and sometimes even loads custom forms. You're required to automate this interactive flow end-to-end using Selenium. How would you simulate realistic user conversation, handle changing DOM elements, and validate that the right message sequence appears during the chat session? Let's say your application allows users to upload images via a drag-and-drop feature, commonly used in modern UI frameworks. The twist is, This component does not use a standard HTML less than input type equals file greater than. Instead, it uses a drop zone area rendered through JavaScript, with backend support to show previews and validate file types. Your task is to automate the upload process end-to-end using Selenium. The challenge? Selenium cannot simulate native OS-level drag and drop out of the box. So, what creative techniques would you use? JavaScript injection, robot class, or any third-party utility to mimic this action and verify upload success? You're automating a business dashboard that presents data visually using advanced chart libraries like D3, JS, or HighCharts. These charts include tooltips, axis labels, legends, and dynamic updates. From a QA perspective, stakeholders want automated validation of chart rendering, tooltips, and graphical consistency. Since these elements are often SVG-based and not part of the traditional DOM, they can't be tested with normal Selenium locators. So, how would you identify SVG nodes, simulate hover actions to reveal tooltips, and assert that the values displayed match expected backend data? You're testing a long, dynamic form that changes based on user responses. For example, if the user selects yes for having prior insurance, additional fields appear asking for insurance details. The form spans multiple tabs and relies on JavaScript-based conditional rendering. Your automation suite must intelligently fill out the form, handle tab navigation, and skip irrelevant sections based on data. How would you structure your test framework, perhaps using data-driven testing and dynamic locators, to build robust, flexible tests for such conditional flows? You're testing a long, dynamic form that changes based on user responses. For example, if the user selects yes for having prior insurance, additional fields appear asking for insurance details. The form spans multiple tabs and relies on JavaScript-based conditional rendering. Your automation suite must intelligently fill out the form, handle tab navigation, and skip irrelevant sections based on data. How would you structure your test framework, perhaps using data-driven testing and dynamic locators, to build robust, flexible tests for such conditional flows? Imagine you're validating a UI component embedded inside an iframe, such as a third-party payment gateway or a feedback form. Some of these iframes are nested, requiring multiple context switches. Moreover, they load content asynchronously, so timing becomes a major concern. Selenium doesn't automatically detect these transitions. How would you build your test script to detect, switch into, and interact with nested iframes? What are your strategies to wait for iframe content and handle frame-level exceptions gracefully? You're testing a secure login system that uses time-based one-time passwords, TOTP, like those generated by Google Authenticator. During login, the user must input a dynamic 6-digit OTP valid only for a short window. Your Selenium script needs to simulate this flow without manual intervention. How do you incorporate TOTP generation in your Java framework? Would you use a third-party Java library, mock the 2FA process in test environments, or find a back-end hook to bypass the OTP for automation purposes? What is your ethical and technical balance in this security-sensitive scenario? You're testing a dashboard that gets real-time updates through WebSockets, for example a livestock ticker or chat feed. Selenium can only observe the UI after it updates, but it cannot listen to WebSocket messages directly. This means you need an alternative approach to verify the correctness of real-time data. How would you structure your test framework to validate that the UI accurately reflects backend state changes, perhaps by combining UI checks with API responses, or direct WebSocket interception using developer tools or logs? Single-page applications, or SPAs, often load different views without triggering a full-page reload. This is common with Angular, React, or Vue apps. As a tester, this causes challenges. Your script might proceed before the virtual DOM is fully updated. Selenium may detect elements that aren't yet visible or interactable. How will you implement wait strategies that are not tied to URL changes, but rather to DOM stability, visibility, and element readiness in a Java plus Selenium context? Your web app includes a Kanban board, similar to Trello, where tasks can be dragged from one column to another. The DOM updates only after the drop completes, and items can be reordered within a column. Selenium doesn't provide native support for HTML5 drag and drop. So how do you test this feature? Will you use the Actions class, JavaScript executors, or advanced libraries like HTML5 drag simulation scripts? How do you validate not just the UI change, but the backend confirmation that the task was moved?